All right, I'll go ahead and introduce Dorothy. Hey everyone, I'm Bibit. I'm very excited to introduce my mentee, Dorothy, who's a high school freshman at Menlo School. Prior to Magic, Dorothy already had experience coding in Java, as well as she got her hands dirty with some projects with her dad, including converting her bike to an e-bike, which is awesome. She's incredibly excited and curious about the physical aspects of her projects and wanted a magic experience that incorporated mechanical, electrical, and software engineering all into one project. She was fearless in her exploration of the deep nitty-gritty details that arose all throughout the project, including terms and ideas that I never even heard about until I was an upperclassman in college. Yet she still never lost sight of the overall picture of the project as well. Aside from being a total boss throughout her entire Magic project, she's also a baller in soccer, as well as always had a list of questions, technical and non-technical, for me at every meeting that we had together. I had a ton of fun working with Dorothy this semester, and I know all of you are going to love what she has to show you. So with that, take it away, Dorothy.
Wow, thank you for the amazing introduction, Bibit. Now I'll be talking about my mentor, Bibit. Bibit grew up in Pittsburgh, Pennsylvania. She got her undergrad degree at MIT, her master's degree at Stanford, and is currently studying for her PhD at UPenn. And overall, she's just a really kind and knowledgeable person, and she's been an amazing mentor to me so far. So I've always been interested in how things work. I've been surrounded by such complex technology, so I always want to take it apart and see what it looks like. But prior to Magic, I, as Bibit mentioned, converted my bike into an e-bike. The kit was a little bit more user-friendly, so I wasn't really able to see what was going on in the back end. But that's why I decided to pursue an electrical and mechanical engineering project. I wanted to learn more about how things worked. So my mentor and I decided on following an Arduino engineering kit to learn the basics of mechatronics without too much debugging. The kit itself had 3 projects: the drawing robot, a self-balancing motorcycle, and a webcam rover. I was only able to complete the drawing robot, but I definitely want to look at the other ones in the future. For my drawing robot, we used MATLAB for the software aspect. It's kind of like a programming language and a calculator combined into one. And we used Arduino hardware, like the microcontrollers and motor carriers. A little bit more about the drawing robot. It can be condensed into 5 main steps. First, it's image processing. The user uploads an image, and that image is applied to some pre-made image filters, basically to get the line traces. And then those line traces are converted into pixel segments, and pixel segments are converted into the coordinates on the whiteboard, and those coordinates are converted into encoder counts and angular displacement, which is basically the position of the DC motor. And then a little bit more about the calculations of that last step. I used trig, some Pythag, some physics to convert the position of the whiteboard robot into the string length and encoder counts, which I thought was really cool. And then for the exciting part, once you run all your code, once you run all your code, as you can see, the DC motors basically unwind and wind the spool, which adjusts the position of the whole robot itself. And the servo motor, which is basically holding the whiteboard markers, also adjusts the position of the markers if you want it to draw or to not draw. And yeah, this is the most exciting part. You get to see all your code and your hard work. get transformed into an actually working machine. On the right, you can see the final product. The lines are a bit shaky just due to the movement of the robot, but I think this was a huge success because of the accuracy and how similar it is to what I actually intended to draw. Yeah. And then in my magical experience, I learned a lot more than I expected. Regarding the hardware aspect, I learned about and how to use Arduino motor carriers, microcontrollers, servo and DC motors, IMU sensors, encoders, PWM signals. And for the software aspect, I learned about the Arduino programming language, how to use MATLAB, how to use Simulink commands and models, PID controllers, and image processing. So overall, I thought this was a super cool experience and super cool project. It was a bit challenging for me due to the mathematical aspect and the precision of the calculations for the whiteboard robot. But I really liked that it was some of everything. It was some electrical engineering, some mechanical engineering, some programming, and some math. So I thought that was cool. The most challenging aspect was probably debugging. I learned that debugging is so frustrating, but it's also like something you can't go without in a programming or engineering project. And my mentor helped me a lot with debugging. I probably would not have been able to finish the project without her. It was a lot of fun also just hanging out with my mentor and talking about other opportunities in STEM. So I really enjoyed my experience with magic. Thank you for listening.